Howdy! Welcome to Intermediate Algebra. I'm your host, Bill Witte, and I'll bet you I can make this quite painless for this long semester. Now, I'm going to need you to know that there is some backup for you during this course. There's a home page, if I talk too fast, at www.montgomerycollege.edu/algebra 2. Remember that this is intermediate algebra, so algebra 2, the number 2. Now, some of you might not have come right to Montgomery College. Some of you might have taken algebra, beginning algebra before this, and you might have forgotten some of it. Just in case, and I'll only show you this one class, note there's another web page, some of you already know it, at www.montgomerycollege.edu/algebra. Okay, so if there's any of this stuff that you've forgotten, we're not going to go over it. Okay, we're going over intermediate algebra. You'll need to go to the algebra web page if there's something you've forgotten. And guess what? What if you've forgotten your pre-algebra? Well, makes sense. Go to the web and you can go to www.montgomerycollege.edu/pre-algebra. Okay? But as for this class, it's www.montgomerycollege.edu/algebra 2. Since this is the first show,
so let it be done.
We need to get a couple things straight. Okay, first of all,
I can do that, but I don't want to.
you have got to record and watch absolutely every show. Okay? At least once a week.
What happened?
What I mean is, if you screw it up, you get 3 chances. It's on at 3 different times every week, and if you screw all 3 of those up, this show is available in every Montgomery College library. So I expect you to watch every show.
If we keep this speed, we'll blow up any minute now.
Well, you know why? Because there's not going to be much review. We have to go over, if you were taking this class normally, you'd be going in 3 times a week. I have to do what would be 3 classes in one 1-hour show. So I'm going to rock and roll, okay? So, yeah. So you're going to need to record absolutely every show. There's not going to be much review. Get the idea? Another secret to success is,
so let it be done.
You're going to have to
Yoink.
do the homework. Now, we're going to give you credit for your homework too, okay? Not everybody does that, okay? I expect you to complete every homework assignment, and you should expect not to pass if you don't. When you do it, even if you get one right, you better know why you got it right, okay? Because you're going to have to do it on a test.
Oh, it didn't work.
And if you get one wrong, you better know why you got it wrong. Don't be afraid to ask, please. And these review tests, a lot of people say, I did the review test, I finished the whole thing with my sister. No. You have to do the review test by yourself. If you can't do it by yourself, you need to look into seeing what you don't know so that you can do it by yourself, because when you get to the assessment center, we know you're going to have to do it by yourself. So
let it be done.
Complete every homework assignment. One more thing.
And you're going to do it because I said so.
You know you're not going to do it because I said so. You're going to take every test because...
Oh, I'm dying!
That's right. Every test you don't take is a 0. That's not just an F. That's a super F. Okay? You know, the average grade on the tests that are taken in these math classes is high. It's between an A and a B. And yet, the average grade for these courses is much, much lower than that. You don't want to know. It's because people get behind and they don't take the tests. And what did I just tell you? If you don't take a test, what grade do you get for that? A 0. So be afraid. Stay up with us. Record every show. Do all the homework. Okay?
So let it be done.
One more thing. You will definitely need, every time you watch this show,
My secret weapon!
a TI-83. Now that's required for this course. I expect you to either have one or go buy one, okay? Now what are you going to buy? A TI-83.
Well, ooh-la-dee-da.
Does it need to be a TI-83 Plus? No. TI-83, it can be, but it doesn't have to be. TI-83 anything and you're hunky-dunky. Get the idea? Now.
I say this calls for action, and now.
So stop the tape if you need to, but I need you to have it in your hand right now. So go get it and bring it back and start the tape up again. Okay, so I'm expecting in a second for you to have that. Now what are we going to cover today? We're going to cover relations, the idea of what a relation is and a function, and the various concepts involved with that. In addition to that, besides understanding them, you're going to have to be able to write it down. So we're going to have function notation, if you would. So note that when you come out of this show, you better know how to write stuff down. Okay, I bet I'll show you how. And we have a little bonus today, as I told you.
No, I can't take it. I can't take it, Jerry. It's too much.
Yep, we can do it. We're going to do it today. We're going to also give you a little bit of a tour of the graphing calculator and start, that's the TI-83, and start to use it a little bit. Okay, we're going to use it every day, though. Okay, where should we start?
It's always best to start at the beginning.
Okay, let's do that. You know, if everybody on this earth, and there's billions of people on this earth, couldn't talk to anybody else. Okay, we had all these people, they can't talk to anybody. You can't talk to your sister, can't talk to your mother, can't talk to your honey. Life wouldn't be very interesting. So it is with numbers. Now, once people start pairing up, that's when it gets interesting. And when we get groups of pairs, well, now you got a party. So it is with numbers.
Do you mind telling me what this is all about, mister?
A relation is a set of pairs. It's like a little party. Okay? Let me give you some examples of relations. Relation A, we'll call it, it looks like it's 4 pairs. It's a group of pairs. It's the number 4 paired with 6, the number 0 paired with 7, the number 6 paired with 2, and the number 2 paired with 6. Very easy. It's 4 pairs, isn't it? Here's another one. Relation B, we'll call it. Now this is a set. You see the green things, the green little parentheses? That says it's a set, that's set notation, of this one has 3 pairs. The pair 1 paired with 2, 3 paired with 4, and the pair 5, 6. Yet another one. I just want you to get used to this. Relation C is 1 paired with 4. Oh, a little bit different here. What's going on here? 1's also paired with 3. 1's a wild man. 1's also paired with 2. 1's also paired with 6. Is that it's still a relation. It's a group of pairs. Okay, don't get flustered if you see something different. How about D? That's kind of backwards of it, but that's yet another group of 4 pairs, so it's a relation. 4 paired with 1, 3 paired with 1, 2 paired with 1, and 5 paired with 1. Now that's certainly different, okay? But, and I bet you're going to expect a different word for that, and we're going to have it. That's what we're leading up to here. Now note the ones in different places there.
Wait a minute.
Note that I said ordered pairs. Don't forget ordered. So the pair 6, 2, for instance, is different than the pair 2, 6. Very important. They are ordered. And to that fact,
Now look at here.
the first numbers, the set of, in a relation, all the firsts, if you would, we have a name for that. Okay? We call it the domain. If this was a computer, we'd call it the inputs. But all the first numbers, here they come, are called the domain. See? Now, you remember that the first numbers in a point or a pair is the x. So you could say that this is all the possible x's that you use in that little party, and that's correct. So the domain is all the possible x's. And you know what? In a formula, you get to pick. We will in the future get to pick what x's we use. So we may call that the independent, because you get to choose the independent variable. So that's what the domain is.
I know you are, but what am I?
Well, if the domain is all the first numbers, we have to have a name for all the second numbers. You know what the name for all the second numbers is? Or if this was a program, the outputs? Well, it's called the range. All the second numbers. Now, you're going to say all the possible y's, and you're correct. If this were points, the first numbers would be the x and the second numbers would be the y's. So the range is the set of all the possible y's. But in a formula, you get to pick what you input, but you don't get to pick what comes out because the formula decides it. So this range or set of possible y's is called the dependent variable because it depends on what you put in and what the formula is. Okay, so get used to all these different fancy schmancy words.
Shall we play a game?
Okay, let's try and name for this relation what would be the domain. Well, let's see. The domain is a set. There it is. It's a set of all the first numbers. I said not all the red numbers. It's all the x's, if you would. And in this case, it's 1, 2, 3, and 4. And the range would be all the second numbers. 2, 4, 6, and 8 in this case. Each one is a set. That's pretty easy, isn't it? Okay, now let's do another one.
Thank you, sir. May I have another?
It gets a little bit crazy here. What is the set that is the domain? All the first numbers. That's easy. Just look at them. I even marked them in red. 0, 1, 2, and 3. Now here it gets a little bit crazy. What is the set of all that? Remember we used the word possible. Possible second numbers. Well, you know what the range is going to be in this case? Just 5. You say, why don't I list 5 4 times? No.
Oh, twice, guys.
No. Once you say 5 is possible, you've said it. You don't have to say it 4 times. In fact, don't say it 4 times. The range, the possible outputs of this relation is 5, the set containing 5. So we're not going to put in repeats. Very important.
How about little fires, Scarecrow?
Well, let's take a look at these pairs. Now you remember that pairs, you can draw a picture of pairs. We call them points. Let's bring some in. Okay, 4 points. Now, let's see. I want to know what the domain is. The domain, as you remember, is all the possible x's. Now, remember, on a Cartesian plane, on an xy plane, the x goes from left to right. So the domain is going to be a set of all the possible x portions of these points.
Perhaps I could be of some assistance.
Oh, I would definitely say so. Let's bring in the x-axis, and you can see now that the possible x's, I'm only looking at the x-axis for the domain. For this bad boy, that's a -6. So that's one of the possible ones in this set of pairs, this relation. 0's the x value for this point, so he goes in the domain. 2's the x value for this point. Don't worry about the y value, so he goes in. And you knew 7 is the x value for this one.
Cool.
So that's the domain of this picture. Well, what about the range? The range is all the possible y values or outputs. So it is a set. And I'll need the y-axis this time because I'm not looking at the left to right position for possible y's. I'm looking at the north to south or position, if you would. Well, it is a set. What's the y value of this? It's 0. That's the height. Don't pay no attention to that -6, right? That's the x value. So that's 0. Put him in there. That's 1. Now, which one do you think I'm going to do next? Remember, we're doing the y's, okay? Well, you didn't think that, did you? We're going with the y's, since we go from smallest to biggest, we're going to go from bottom to top, not left to right. So 2 gets it. Pay no attention to that 7, because that's the x. And last one, that's a 5.
Correct, boy wonder.
Okay, so there's your domain and range. Get the idea?
Do that again.
Okay. We'll do a little bit easier. It looks harder, but it's going to be easier. Bring in some points. Well, this one's crazy. Okay, remember the domain is all the possible what? All the possible first numbers or x's. Well, let's see. Bring in the set marker and your buddy, the x-axis, because that's all we want to look at here. The first point will be a 2. The next point, as far as x is concerned, is a 4. Pay no attention to that 5. The next one is a 6. And the next one is a, and I think I've run out of points. Yes! So that's the domain. That's all the possible x's, at least in this picture. Now the range, of course, as we said, is all the possible y's.
Uh-oh.
So we need that axis. Okay, we can do this, but it is a set. We're trying to trick you here. It's a little bit smaller. Why would it be a little bit smaller? What's the y part of this point is a 5. So he definitely goes there. Now what are you going to do with the second point? It's a 5 also. You're going to put another 5?
I know that, dude.
No, you're just going to leave it right there. There you go. That's a possible. You already said it. It's still a possible, so don't put it in again. The third one?
I know that, dude.
You already know it. Last one?
Believe it or not.
And that's it. The set just containing 5 is the range. That's it. Okay, you said it, you meant it, you do it. Uh-oh. How about this one? This is way more points when it gets continuous. Well, let's take a look at this bad boy. The domain for this, still a set of points or set of...
That's the fact!
It's still a set of points or pairs. Well, let's see. Possible x's. It's going to go from what to what? From 2 to 4. Okay, but it's a whole bunch of points. Now, there's more points than that even. The points are very little size. In fact, it's an infinite number of points, so we're not going to be able to list all the points. We're going to have to use some special notation.
Excuse me?
That's what we're going to do. You know what this is? This is the set
Nerd alert!
of all x's. That black line there means such that. The set of all x's such that, and here's how you're going to read it, because we care about x. We're going to say x first. X is greater than 2, and x is less than or equal to 4. You could also say all the x's between 2 and 4, including 4, but not including 2. Okay, because there's an infinite number of points here for this width. So you're going to have to use what is interval notation, or inequality notation, if you would. Now, for the range...
Now what am I gonna do?
Well, let's see. That's the possible y's. Or the height, if you would. Goes from what, 0 to 6? It's a whole bunch of points. In fact, it's an infinite number of points. Okay, we don't want to include 0, do we? We do want to include 6 and everything in between.
Excuse me, Professor Brainiac.
Well, here's what you're going to do. You're going to have this notation, which is read, the set of all y such that, that's that black line, such that y is bigger than 0 and y is less than or equal to 6. Note that there is a little equal thing under this, the one with the 6, but not under the one with the 0. Well, that makes it a little bit difficult. Let's remember this endpoint summary thing, okay, so that you know. When we have a solid circle, that means we want to include that point, doesn't it? So, you're going to either use greater than or equal to or less than or equal to. When we have an open circle,
You're absolutely correct.
that means don't include the endpoint, doesn't it? So what are you going to use there? Either a greater than or a less than or greater than. Get the idea?
Alrighty then.
Okay, let's try another domain and range. I think practice makes perfect here. In this case, all the possible x's of what we have here, an infinite number of points, we're going to have to use inequality notation again. It's going to go from 0, and then it's going to go...
To infinity and beyond!
So we're going to have to go forever. So how are we going to do that?
Welcome to Fantasy Island.
We need an inequality.
Fascinating.
That's going to be read, all the x's such that x is, we wanted to include 0 here because there's a solid dot on it, such that x is greater than or equal to 0. It doesn't stop anywhere. So that's how you do it. For all the possible y's, well, that's real easy here. That's it. That's all the possible y's.
You're absolutely correct.
You could say all the y's such that y equals 4, or you could have just listed in the set 4. Okay? That was a fancy way of saying it.
As always, should you be caught or killed, the Secretary will disavow any knowledge of your action.
This one looks hard, but it's not that bad. We have a new concept, though. Remember that the domain is all the possible x's, or how wide this thing is, right? Because x goes from left to right. Holy, go to war. This thing goes on forever in the negative direction and forever in the positive direction.
Pay attention, son. This is for your own good.
I know that because of those arrows. So how am I going to represent everything in both directions, if you would? Well, I'm going to say all real numbers. I got a fancier way to say it, though.
Well, ooh-la-dee-da.
Yep. If I use this symbol, that means all real numbers. Okay? Or you can write it out if you want to. But if you see that symbol, you'll know what it means. That's the set of all real numbers. Now, the range is all the y's. That isn't all real numbers because this thing only goes as low as 0, doesn't it? It starts at 0 and goes up high.
To infinity and beyond.
Okay? So how are we going to say that? It's not going to be all real numbers. It does go forever. So we're going to say all the y's such that y is greater than or equal to 0. And that'll do it. That's the height of this bad boy.
And now for something completely different.
Okay, now there's a special type of relation. These have all been relations, but there's a special type of relation. And you know what that's called?
Well, isn't that special?
It's called a function. And you'll need to know a function. They're going to be quite useful. What makes a relation a function?
Wait a minute.
Yeah, well, you need to know. Is that every element in the domain is paired with a unique, a fancy word unique, is paired with only one element in the range. Let me give you another way to say that. How about every x is paired with only one y? You've got to check, and if every x is paired with only one y, you've got a function. It's still a little bit difficult. How about this?
Brain is gone.
Yep. How about all the x's are different? If all the x's are different, you've got a function. That's the way I do it. Okay, but that's the idea. Every x is different.
Allow me to demonstrate.
Well, let's see. We've got these 4 relations that we worked with before. Relation A. Is this bad boy a function? Well, what are we checking for? Are all the x's different? 4, 0, 6, and 2. They're all different.
Yes!
So we've got ourselves not only a relation here, but it's a special type of a relation. It's a function. No x is paired with more than one y. This one gets the function seal of approval. Let's look at the next one. Relation B. Now, this is a set of 3 pairs. It's certainly a relation. Are all the x's different? Well, the x's are, hope you understand, 1, 3, and 5. And they certainly are all different. It's not a very fancy relation, but it also, since no x is paired with more than one y, it also is a function. It gets the function seal of approval. Now, you think everything gets the function of a seal of approval? Not the case. This relation, a set of 4 pairs.
Wait a minute.
Uh-oh. All the x's are not different. In fact, they're all the exact same.
Oh, yes.
And it only takes one to screw it up. Okay? Now you see, I see 1 paired with 4 and the number 1 paired with 3, and I can go on with other problems in this relation, but it only takes one screw up. So,
Nothing for you.
that's it. This is not a function. I can stop right there. It is a relation, but it's not a function. Now how about this one? This one looks similar. This one looks like it would be a screw up also, doesn't it? But remember what we're only dealing with in one direction, pairing up x's. Well, are all the x's different? Actually, all the y's aren't different, but that doesn't matter.
Giddy up.
So we're good to go. Every x is paired with only one y. Now it's the same y, but that doesn't matter. Okay, you're only working in one direction here. So this one, believe it or not, does get the seal of approval. So remember, what we're looking for is all the x's being different. You got it.
Prepare to be astonished.
Now we can test whether a relation is a function graphically. And let me show you how to do that. It's pretty cool. It's easy too. Because we're testing to see if any x is paired with more than one y.
Excuse me, Professor Brainiac.
Well, let's see. We're going to do
Are you pondering what I'm pondering?
what's called the vertical line test. Now in this picture, I'm going to look for any x paired with more than one y by running a vertical line across the picture. And if it hits my green graph here in more than one place, well then some x is paired with more than one y. Okay? But if it doesn't, if it gets through the whole picture without hitting it in two places, you've got yourself a function. There it goes, there it goes, there it goes. Ooh! It worked. This relation is a function.
Do that again.
Let's try another one. This is a totally different picture. It's a bunch of points. But remember what we're looking for if we're going to do this graphically. It never hit it in more than one place at the same time. It's simple. It's quick, isn't it? So it is a function.
Thank you, sir. May I have another?
Absolutely. What about this one? Oh, that one hit it in more than one place. This is not a function. It's a relation, but it's not a function.
Survey said.
Didn't work. Okay? How about this one? Don't be afraid of these things. Just do the same test. We're seeing if this is a function by doing the vertical line test. Never touch twice. You got yourself the function seal of approval. How about this one? Have you seen this one before? I don't know. Anyway, we're going to do our vertical line test to see if it's a function. Slowly. We got a problem. It hit it in two places. Now I could find you other places where it hit it in two places, but it only takes one to screw it up. So we've got a problem. While it is a relation,
Nothing for you.
it's not a function. Get the idea? Anybody ever seen this one? This relation? Yeah, if you study waves of any kind, radio waves, water waves, or everything, I bet you've seen this.
Excuse me, Professor Brainiac.
Yeah, that's the sine function. Now, I'm not covering that in this class, but just in case you knew, that's the sine function. Well, let's see if the sine function, is a function using the vertical line test. Never hit, never hit, never hit, never hit. Oh, the sine function, obviously, is a function. Of course, that's why we call it the sine function.
But now you know the rest of the story.
Okay, that's why we call it a sine function. Anyway, that's what it looks like.
And now, ladies and gentlemen, let's get ready to rumble!
Okay, now, a function is a special type of relation. There's a special type of function called a one-to-one function. Okay, and I think that's what you like the best. What makes something a one-to-one function? Well, let's see. It's one-to-one function if every element in the domain is paired with a unique element in the range. Well, geez, that sounded like a function. Well, there's more to it. Can't just have that. That's the same thing as a regular function. In addition to having every element in the domain paired with a unique element in the range, you also have to have every element in the range is paired with a unique element in the domain. So it's got to work both ways to be one-to-one. How about this? Every x is paired with only one y, and every y is paired with only one x. You still don't like that.
I'm trying to think, but nothing happens.
How about this? The easiest way to detect whether a function is a one-to-one function is if all the x's are different. Okay, that makes it a function. And all the y's are different. Then you got yourself a one-to-one. Everybody's unique. Now remember, So it only takes one, just like with testing for a function, it only takes one to screw it up.
If you don't start making more sense, we're going to have to put you in a home.
Oh, wait a minute. Let's see. For instance, this first one. Is this a one-to-one function? Are all the x's different? Well, yeah, they are. That's why, because it was a function.
Oh, it didn't.
It didn't work. All the y's are not different. So while this is a relation and it is a function, it's not a one-to-one function. It only takes one to screw it up. Not a function, but not one-to-one.
Oh, very bad. Definitely unacceptable.
Okay. How about this one? It is a relation. All the x's are different, so it is a function. All the y's are different, so it is a one-to-one function. Everything's unique. That's as good as you can get. A one-to-one function, baby. Let's look at this one. Are all the x's different? Wait a minute. The x's aren't even different in this one. So this one, while it is a relation, it's not even a function. So it's certainly not a one-to-one function.
Nothing for you.
So that's it. Remember, it only takes one to screw it up. And this one, all the x's are different, so it is a function. Is it a one-to-one function?
Ooh, I'm dying!
No, it's not. While it is a function, it's not a one-to-one function because all the y's aren't different. So, function, but not one-to-one. Okay?
Prepare to be astonished.
Okay, now, this is really cool. We can not only test whether a relation is a function graphically, we can also test whether it's a function that is a one-to-one function graphically. Now, it's going to take two tests. We're going to have to test to see whether it's a function with the vertical line test, and then we're going to test to see whether it's a one-to-one function with what I'll show you is the horizontal line test. Take a look. We'll do the vertical line test to see that it's a function, and
Ay, caramba!
we'll do another test to make sure that it's a one-to-one function. And that's not only the vertical line test. Well, that passed, didn't hit anything in two places. We'll do the horizontal line test. I bet you guessed that, so that there's no two y's. And there it is, it worked. So, this bad boy is not only a function, but a one-to-one function. Most lines are.
Do that again.
Okay, let's do another one. How about this picture? Well, let's start with our vertical line test to make sure it's a function in the first place. Oh, it's looking good. Didn't hit anybody in two places. And we want to test it if it's one-to-one. We'll do the horizontal line test as well. We got a problem. So, this one is a function. It's not one-to-one.
Thank you, sir. May I have another?
Let's do another one. We got a relation. We'll see if it's one-to-one. Let's do the vertical line test to see if it's a function.
You look marvelous.
Oh, it made it, baby. And let's do the horizontal line test to see if it is a one-to-one.
Hey, this is great, man.
It worked, baby, and it's not that hard, is it? Okay, you just have to know which test is which. So, this one is not a fancy one, but it is a one-to-one function.
Uh-oh.
How about this one? Let's do our vertical line test, see if it's a function.
Well, your story is very compelling.
Son of a gun, it is a function. It never hit it in two places. But what about the horizontal line test?
Wait a minute.
Uh-oh.
We got a problem. And remember, it only takes one problem to screw it up. Okay, now that didn't screw everything up. It's still a function. It's just not a one-to-one function. Okay, so we have a function, but not one-to-one.
Oh, very bad. Definitely unacceptable.
Not that bad.
Yeah.
Remember this relation? You remember this from previous. This is a parabola, isn't it? Is it a function? Well, let's do the vertical line test. Oh, I hear that seal of approval. Is it one-to-one? Let's do the horizontal line test. Not 1-to-1. It hit it in two places.
I'm back, baby!
Oh, there's your buddy, the sine function. We know he's a function. We knew that already.
I know that, dude.
But is he a 1-to-1 function?
There's something I have to ask you.
Well, let's see. Let's do our horizontal line test. Oh, now the sine function, we're not covering the sine function, but you know it's cyclical. It keeps coming back, it keeps coming back. So you shouldn't be surprised that no, it is a function, but it's not a 1-to-1 function. It only takes one to screw it up. This has an infinite number of points to screw it up. Okay, so.
Hey man, check it out, huh?
Now the cubic function, I'll show you one cubic function just to show you, just looks something like this. That's weird. Get used to it. We'll see that a little later. Not today, but a little later in the course. Is it a function? Oh, we're looking good. Is it a 1-to-1 function? Cool. This one is. They aren't all, but this one is, because it passed both tests. Got the idea? Well, if you have that idea, we can talk about the inverses of functions. That's going backward. The inverse of a function is going to be the way to get back. What do you mean the way to get back? A function, remember, goes from x to y. So this is going to be a way to get back
I know that, dude.
from y back to x.
Whoa!
Now, it's going to be important, if you want to find the inverse of a function, that's why we covered this before, that the original function is 1-to-1, because if the original function isn't 1-to-1, then there isn't any way back that is a function, is there? That's it, dead endsville.
Allow me to demonstrate.
Take this relation here. It's a set of ordered pairs, and it is a function, because there's no two x's that are the same.
Excellent.
Now, if we wanted to get the inverse, what I would do, quite simply, is take all the x's, or the domain, and put them in the y's, and take all the y's and put them in the x's, the domain. And that's the inverse of this, the switcheroona, if you would.
Direction unclear. Please repeat request.
Okay, let's do another one. How about this relation? It is a function, isn't it? Because no two x's are the same. It is a function. All the x's are different. Let's do the inverse. Take all the x's and put them in the y's. And take all the y's and put them in the x's. Now, what's the problem with this inverse function? Uh-oh, all the x's aren't different. Well, then it isn't an inverse function. In fact, it isn't a function. Why couldn't we do it on this one?
Oh, very bad. Definitely unacceptable. Yeah.
You can't handle the truth.
Well, the reason we couldn't find an inverse function on this one is because the original schmiginal wasn't a 1-to-1 function. To be able to have an inverse, you have to be a 1-to-1 function. That's why you love 1-to-1 functions, because you can get yourself out of trouble. You can get your way back. Get the idea? We don't need to talk too much more about inverses, though.
That's the last straw. Now I use my secret weapon.
Okay, I hope you have your calculator out. I want to do a little review, or a little tour, if you would, of how we're going to map pairs on your graphing calculator, hence the term, using this thing. Let's take a look. Let's graph some ordered pairs. How about these ones?
Oh, boy, is this great!
Now, you got your graphing calculator. We'll do this twice. We'll do it fast here. Let me tell you what we're going to be pushing, though. Of course, the on button. That's the enter. When I say enter, know where that is, okay? That's the graph button. You might not have used that, but note where it is. The stat button. The y equals button. We'll be using that a lot this semester. Now, the second button, it's orange, and anything that is orange, that's the way we're going to get to it. We're going to have to hit the second button first, okay? For instance, stat plot is orange above y equals. So to get stat plot, you're going to hit second and then y equals, and you'll get stat plot. There's L1. We'll be talking about list 1. Note that it's orange and it's above the number 1. Same with L2, L3, etc. So you'll have to hit the orange button first and then whatever you want as far as if it's orange. When I say the cursor keys, this is what I'm talking about. Okay, up, down, left, and right, and you'll be using those. And the clear button, that's going to get you out of any trouble. Okay, it's going to get you, if something's on the screen you don't like it, just hit clear and it'll get you out of trouble. Or turn your calculator off or throw it out the window. That'll do it for you. Okay, now we're going to turn it on. It may already be on. And then you're going to hit stat plot. That's the same as hitting second and y equals. We're going to do some points. Now we've got to turn on plot 1. If you don't see how to do that, I'm going to show you how to do that. You've got to cursor over and turn that off to an on. And then clear gets us out of that. Now that turns plot, the ability to plot, on. We haven't plotted anything, we just turned on the ability to plot. Okay? Now we've got to put some numbers in there to do it. Hit stat, the stat button, and that gives you a whole menu of things that you can do as far as statistics really. And you'll hit edit, or you can either hit 1 or enter on the number 1, that's edit. And that gets you into the little statistics editor. And we're going to enter the points that we have here, 1, 2, 3, 4, 5, 6. The domain will be in all the L1s, and the range will be in all the L2s. And once you've got them all in there, you'll hit graph and you'll see those points. You're going to love this, okay? And once you're done looking at the graph and patting yourself on the back, we're going to
I have to ask you.
We're going to see, is this a function? Okay? And then we'll hit clear. Let's do it on the graphing calculator. I'm going to turn this baby on. And I'm going to hit stat plot. That's second, y equals. And that gets me into this now. As I can see, plot 1 is off. So I'm going to hit enter, or 1, and move over. Actually, I'm on the on. See how I can cursor over to the on, and I'll hit enter, and now it's on. I see that the off is not bolded, and I can hit, how can I get out of here? How do you get out of anything? I'm going to hit clear. Okay, now the ability to plot points is now on. Now I'm going to hit the stat button, find the stat button, and it gets me into the statistics menu, if you would, and I need to go into the editor. So I'll hit either 1 for edit, or since I'm already sitting on 1, I'll hit enter. Okay, now I'm going to put in all these points. I'm going to move back and I'm going to put in the point 1, 2 by hitting 1 and hitting enter. Now I'll go up here and put in a 2 and hit enter. Okay, there's the first point. Now let me put in the point 3, 4. 3, enter. Come over here. And 4, enter. Okay, and the point 5, 6. 5, enter. And come over here and put in a 6, enter. Well, guess what? They're in there now. All I have to do now is hit graph. The graph button. Find the graph button. And there they are, pretty cool as a mule, huh? You see those points? And how do we get out of this? Well, we hit clear. Okay? That's how you do it. Well, you're going to find you don't want to leave your calculator like that, because if we want to draw any other picture other than a bunch of points, like a line or a curve or something that's continuous, we can't leave it in plot mode. So it's important that I'm going to have to show you how to turn plot mode off, especially if you're going to loan your calculator to somebody else, or if in the future we're going to be drawing continuous lines. Okay, the way to do that is to go into stat plot, which is second y equals, and we'll cursor over to the plot where, well, you'll hit enter actually, and it'll give you the ability to turn it on or off. And we'll make sure that that off is bolded, and then we'll clear, and that gets us out of there. Now that clears it, but it also doesn't take all those points that we have in list 1 and list 2 out of there. And there's a way to do that, and I want to show you it. If you hit the stat button Now you could go in and do each of them by hand, which we'll do later, or you could say clear the whole dad burn list. If you hit clear list, which is either cursor down to the 4 and hit enter, or just hit the number 4, and then it says which list do you want to clear? Well, you'll have to type in L1, and the way to type in L1, remember, is to hit your second button, since L1 is orange, second, and then the number 1, and then enter. And it'll say, I cleared it. And you'll feel good about that. We've cleared out L1, list 1, but we haven't cleared out list 2. So you'll hit Stat, and you'll say Clear List, and it'll say which list do you want me to clear, and you'll say List 2 by hitting second and 2. Note that, it's kind of crazy, you can't just hit the number 2. You have to say L2. It'll go all get all mad at you if you just hit the number 2. I'll show you that in a second. And then we'll hit enter, and it'll be clean and green, ready for the next guy. And you'll know that, because if we hit graph, everything will be blank. You'll know those points are gone. Okay? Let's take a look. Clear will get us out of there. Let's see. I got to clean up shop here. Well, I'm going to hit stat plot, so second and y equals, and I can see that the plotter is on. So I'm going to either hit 1 or enter and move over and turn it off. Okay, I'll hit enter to make the off brighter, and clear gets me out of there. Okay, now I've turned the plotter off, but I still have those points stored in there. So let me hit stat, and let's go and clear list. I can cursor down to 4, or you lazy people can actually just hit the number 4. But I'll cursor down to 4 and hit enter. And it says, which list do you want me to clear? Well, if I need to clear list 1 and list 2. So let's see. Second and list 1, enter. It's done. And now I need to clear another list. So I'm going to hit stat, cursor down to clear list, and list 2, second and L2, and it's done. Get the idea? Let's hit graph to see. Oh, you like that, it's gone. So I'll hit clear, and I'm goody goo goo. Okay, let's take a look. I want to do
that again.
Yeah, let's do another one, because that was a little bit tough. Okay, we're going to do it for some different points.
Bring it on.
Let's do 4, 1, 3, 1, 2, 1, and 5, 1. Okay, remember where all these are. There's the enter, there's the stat button, there's the y equals button, the cursor keys we're going to be using, the graph button, don't forget your second, anything that's orange, and the stat plot. Okay, there's your list 1 and list 2. We're going to be talking about that. And clear gets us out of trouble. We're going to turn it on if we still need to. We're going to hit second plot, or second y equals to get stat plot. And then we're going to turn plot on. Remember, we had turned it off. You don't have to turn it on if you left it on. And then we're going to hit clear to get back out. And we're going to hit the stat button. We're going to start putting these points in. We'll edit and start putting them in. Enter all those points with the cursor and enter. And then we'll look at graph, and they should be there. Hopefully they will be.
There's something I have to ask you.
And we'll try to see if, in fact, this is a function. Okay, and then we'll clear. Let's take a look. Okay, well, let's see. I turned it on. I'm going to hit stat plot to turn this bad boy back on. So second y equals, and I see that it's off, so I'll hit enter and turn it on. Okay. Now let me clear to get out. Remember how to do that. Now I got to get the points in. So I'll hit stat, edit, and the points, you may remember, were 4, 1, 3, 1, 2, 1, and 5, 1. So 4, I'll go to 1 and enter. Now actually they're 3, 1, 2, 1, and 5, 1, so I could go 3, and it moves down, 2, and 5. I could get fancy and do it in another order. And 1, 1, and 1, couldn't I? And I have those points. Are you sure? Let's hit the graph button. And son of a gun, there they are. Okay, and what's going to get me out of this? Before I get out, is it a function? Well, it's not. It is a function, but it's not a one-to-one function. Okay, so let's clear to get out. Okay, that was a good quick one. Let's do one more. Okay, one more.
How about a little fire, Scarecrow?
It could get tough. I want to do these points. I didn't turn it off yet, so I can still leave it on. I want to do 11, 12, 13, 14, and 15, and 16. And I'm going to do that by deleting the old points. Note where the delete button is. Okay, we're going to do a shortcut here. I'm going to hit Stat. I'm going to edit, go into the editor, and I'm going to add all these points and take all the other ones out at the same time. Get the idea? And use delete if you need to, the DEL button. And then I'll enter the new points.
Houston, we have a problem.
And hit graph, and I want to show you something. Okay, let's try it. Well, let's see. I'm going to hit Stat, and I'm going to go into Edit. And the points that I'm going to have to delete the old ones. So I'm going to move to them, and I'm going to hit the DEL button. Move to each one. I can just hit delete a bunch of times in a row, and it gets rid of it too. Try it. Hit delete, 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 or you could overwrite them. Okay? Let's put in these points. I'm going to put in 11. Got a cursor down to get there. 11. Got to hit enter. 12. So it's the point 11, 12. Then I have another point, 13, 14. Just doing that so you can remember them. And 15, 16. Okay, now I'm going to hit enter, and I'm going to hit graph. Let's see these things. Now, we got a problem. I'm not seeing them. What is the problem? Well, I'll tell you what the problem is. We're in too close. We have to adjust our zoom, and that's what I want to talk about here. Okay? Let's talk about zoom.
What happened?
Well, what happened is that our zoom was misset. Now, if you're in too close, we're going to have a problem, right? Or you could be out too far. And this is going to happen all the time with your calculator. So let's show you how to adjust your zoom. We're going to be using this all semester. There's a couple zooms.
Ooh, yes.
There's your zoom. There's zoom box, zoom in, zoom out, and zoom standard, which is what we're set to right now, okay, but apparently it's not appropriate, okay?
Cool.
And zoom stat, which automatically just makes everything fit. You love that. And remember, we had other things other than stat points. We had continuous lines.
Baby, you ought to...
That's going to be zoom fit. That's going to make those things fit in general, okay? So I want to demonstrate those for you at the calculator, and we'll fix our problem here, okay? Let's take a look. Well, let's see. I got to get to zoom. I'm going to clear out. I'm going to hit clear, and I'm going to hit the zoom button. See what we have here? Remember I told you we could do zoom box. If I hit enter on box, it's going to ask me to move around my cursor. See the cursor? And I'll hit enter for the top left of the box and move down and maybe move down and to the right, and I'll hit enter on the bottom right of the box. Well, that's no good, but that's the box, okay? You can pick whatever box you want. I picked the wrong box. Let's hit zoom and zoom out. I'll hit 3 or cursor down to 3 and hit enter. Okay, I zoomed out a little bit, hit enter again, and it zoomed out. I still don't see it. Let's try, they must be way out there. They're high numbers. Let's hit zoom standard. Go to the regular schmegular. There it is. Now we need to zoom out again. Let me hit zoom and out. And I'll hit enter. There they are. Remember, they were up at 11, 12, and 13. The standard is a 10, a size 10 by 10, etc. There they are. Now if I zoom in zoom, zoom in. Now you're not seeing them anymore. Okay, so you get the idea of zoom and how you're going to have to know how to do that. If you're in too close, you zoom out. And if you're out too far, you zoom in. And if you don't care, we'll hit zoom and start with zoom standard. Okay, note, by the way, let's move down. Your old buddy zoom stat says fit everything you got. You love that. That's as close as you can get with still fitting them. Let's go back to zoom standard. And of course, we don't see them. And zoom out. There they are. Okay, so you get the idea of what we can do with zoom. Well, that's enough about zoom, and I'm guessing you're saying, I've learned quite enough about everything today, thank you very much. So, you know what time it is now. You've got to go do that homework, and you have to do absolutely every problem. We expect you to do all these problems, okay? I hope to see you next week, right? I expect you to watch every show. And remember, on the homework, we don't study homework in math. What do? We don't study it. We do it. Pick up the pencil or the pen and actually write. Okay? I expect you to do don't just look at it. Okay? And if you have trouble, remember, you can go to the webpage at www.montgomerycollege.edu/algebra. I thank you for listening. Note that we didn't do much review, did we? Okay, you got to listen every time. Thank you for listening. Thank you very much. Bye-bye.